Hello friends, welcome to Daring Mariner YouTube channel. Today we will be discussing continuation of that last topic. What are the problems that can happen during our engine room watch? So we will be discussing some list of problems that can happen during our watch. Mainly first, crankcase explosion. So for a crankcase explosion to happen, there should be need of a source of heat or ignition, which requires for that our oil should be get vaporized into a fine vapor. Okay. For this crankcase explosion to take place, the correct air to fuel ratio is also required, and fine oil vapor with high surface area to mass ratio. So these three are the conditions for a crankcase explosion to take place. A heat source of ignition is required to vaporize the oil, then correct air to fuel ratio is required for explosion, and fine vapor with high surface area to mass ratio is also needed. The source of ignition mainly due to a hot spot. These are created due to the bearing running hot. This heat causes lube oil in contact with hot surface. When lube oil get contact with hot surface, they will get lube oil get vaporized into fine vapor, and this oil vapor forms an oil mist in presence of condensation in a reality cooler section of the crankcase. Okay, so the main source of ignition means oil vapor will be producing. When how they are producing means the bearing will be during running bearing will be getting very hot. So when lube oil come in contact with this bearing or in hot surface, it will get vaporized and changes into a fine vapor, and this oil vapor forms an oil mist, and due to condensation this will move to the cooler sections of the crankcase. When this fine oil mist ignites in the presence of hot surface, the pressure rise occurs. Depends upon the weakness or richness of the oil particles, and explosion occurs. If all came in the range of the explosion range. Okay, when this that is mentioned, when this fine oil mist ignites in the presence of hot surface, pressure rise increases. Depend on the weakness or richness of the oil particle in the air ratio. A primary explosion, the first here takes place. Primary explosion, this will be relatively slow or relatively not that much effective as compared as the crankcase atmosphere is too rich with oil vapor, but this may cause a rupture or damage to the crankcase door, allowing ingress of air. This ingress of air causes very good air to oil particle ratio, and this will lead to secondary explosion, which is more fatal and violent. The remedy for the secondary explosion is the use of crankcase relief valve or crankcase relief door, which relieves the crankcase pressure if it exceeds 0.05 bar, so thereby preventing any rupture to the crankcase and ingress of air. So the chance of secondary explosion is also avoided. So constant monitoring of crankcase oil mist is accomplished using an oil mist detector. Here is the picture of a crankcase relief valve. These are self-closing crankcase relief valve fitted at various points in the crankcase to relieve pressure if it exceeds 0.05 bar, irrespective of the origin in the crankcase. This valve should be self-closing to prevent the ingress of air, which leads to a secondary explosion. The self-closing function is achieved by a spring which shuts the disc valve, and if the crankcase pressure is less than 0.05 bar. Okay, here in this crankcase relief valve there is also an oil wetted metallic gauge fitted on the internal side for stopping the flame emerging from the relief valve. So inside this apart from this relief valve, this crankcase relief valve consists of an oil wetted metallic gauge. So this is fitted inside internally for stopping any flame emerging inside the or from the relief valve. A rubber o-ring is also provided for the oil tightness and sealing, and here the deflector is also fitted in this crankcase relief valve to deflect any flame or pressure wave in case of explosion. Okay, so let's move or look into this crankcase relief valve in a quickie way. Here what is self-closing relief valve are fitted, can be fitted at different parts of the crankcase, and what should be self-closing to prevent the ingress of air that may lead to secondary explosion. So this self-closing function is achieved by a spring which shuts the disc valve when the pressure exceeds 0.05 bar, and here oil wetted gauge or metallic gauge is also fitted from the internal side for preventing the flame emerging from the relief side, and rubber o-ring provides the oil tightness and sealing. A deflector is fitted to deflect any flame or pressure wave in the case of an explosion. And another very important incident that may happen during your watch is scavenge fire. Scavenge fire, it is mainly due to ignition of carbon or cylinder lube oil deposits. Scavenge fire, we have mostly heard about crankcase explosion and scavenge fire. So scavenge fire, it is due to ignition of carbon or cylinder lube oil deposit. Mainly cause are blow past due to worn or damaged piston ring, stuffing box leaks, excessive cylinder lubrication, inadequate draining of scavenge space, poor combustion or injector condition, fuel timing or worn liners. So scavenge fire means it mainly ignition of carbon or cylinder oil deposits. Therefore, this to happen, blow past due to worn or damaged piston ring may be damaged, then stuffing box leaks will be there, cylinder lubrication will be excessive, then inadequate draining of the scavenge space is not properly drained, then also chances are there, then poor combustion, injector condition or fuel timing or worn liners may be or leads to scavenge fire. So what are the indications before this scavenge fire to happen? We can have some indications. So indication means increase in the scavenge temperature of one unit as compared to other, increase in temperature in scavenge and exhaust system, a rough running of engine with slight RPM drop and surging of turbocharger, smoky exhaust, flame, smoke or sparks at scavenge ring. Okay, these are some of the indications that we can see, that we can understand that this may be reason for a scavenge fire, that are increase in scavenge temperature of one unit, then increase in temperature in scavenge and exhaust system, rough running in engine with slight RPM drop and surging of turbocharger, smoky exhaust, flame, smoke or spark at scavenge rings. For scavenge fire, if you want to prevent scavenge fire, what we have to do is, so regular draining and cleaning of the scavenge space should be done, and correct rate of cylinder lubrication should be provided, it should not be excessive, then correct maintenance of piston ring, cylinder liners and fuel injection equipment should be done. Also, we have to properly maintain the machine for running it properly, that's what it means. For the prevention of scavenge fire, we have to do regular draining and cleaning and monitoring of scavenge space, then correct rate of cylinder lubrication, then correct maintenance of piston ring, cylinder liners and fuel injection equipment. Here some remedies that we can see in some Sulzer engines are, what we can do is, if there is scavenge fire, slow down the engine, we can cut off fuel, we can increase cylinder lubrication and continue running until the fire burns out, and after that stop the engine. After wait for some time till the scavenge space cool down, then open up for the inspection and we can ascertain what are the cause. So remedy in the case of here we discuss is Sulzer engine. Sulzer engine means we will slow down the engine, cut off the fuel supply, then we will increase the cylinder lubrication and continue running for until the fire burns out, and after that we will stop the engine. Then we will after waiting some time, then we will wait some time till the scavenge space cool down, then we will open up for the inspection and we will ascertain the cause. In BMW engine, we will cut off the fuel, slow down the engine, when we will request the bridge or inform the bridge to stop the engine, and we will slowly stop the auxiliary blower also. Then we will apply extinguishing medium, allow the scavenge space to cool, then open up for inspection and we will find out the cause. Then we can understand the components affected by scavenge fire. What are the mainly piston rod, cylinder liner, stuffing box, piston alignment, cracks in the liner or tie rod tension and all we can ascertain. In BMW engines, we will cut off the fuel, slow down the engine, then we will inform the bridge, then to stop the engine and auxiliary blower, then we will apply extinguishing medium, then we will wait for the scavenge space to cool, then after that open up for inspection and we will ascertain the cause. Then we can check the components mainly affected by the scavenge fire, mainly piston rod, cylinder liner, stuffing box, then piston rod alignment, then cracks in the liner and tie rod tension and all. Okay, so another effect or fault that can happen during our watch is oil spill. This can happen any time in our ship. Oil spill. In case of an oil spill, stop the fuel oil transfer operation and raise the general alarm. Follow the oil spill contingencies plan. Identify the source of spill. Immediately restrict any further oil spillage by isolation. Drain and contain the oil on the ship by putting the oil into a slop tank or an empty cargo tank. Clean the spill area using an oil spill dispersant and the gear from oil spill storage station. Try to recover as much oil as possible, and we should log events and communicate with the port authorities. Here what mentioned is oil spill. So during oil spill, if there is an oil spill, we should immediately stop the fuel oil operation, and we should raise the general alarm, and we should follow as per the oil spill safety contingencies plan. Then we should identify the source of spill and immediately restrict any further oil spillage by proper isolation, and we should drain and contain the oil on the ship by simply putting the oil into a slop tank or an empty cargo tank. Then we should clean the spill area using oil dispersant and try to recover as much as oil as possible and log events and communicate with the port authorities. Another fault that may happen during your watch is collision. In case there is a collision of ship, we should stop the main engine. We should activate the emergency general alarm. Engine room should be immediately manned. In case of if there is UMS mode, it should be general alarm should be done, and everyone should be there on engine room. We need manpower, and we should check if there is any ingress of water into engine room. We should take sounding of all double bottom tanks to check that they are intact, and we should keep all firefighting gear on standby, and we should check for any oil pollution around from the ship. Then we should check all machinery to see if they are affected, especially the electrical part. Then we should report to the bridge and to the condition of the engine room and main engine and auxiliaries. If there are well, then we should inform that. Then master will assess the danger of sinking, capsizing or flooding and all, and designated person assure the superintendent of the ship and port authorities should be informed. So in case of collision also we should stop the engine, and we should immediately raise the general alarm, and if the ship is in UMS mode, all persons should be there. Engine room should be manned. Then if there is ingress of water, we should check the ingress of water in the engine room, and we should take sounding of all tanks, mainly of the double bottom tanks, to check they are intact, and we should keep all firefighting equipments on standby, and we should check if there is no check for an oil pollution from the ship, and we should check all machineries to see if they are affected, mainly especially in the electrical side, and report to the bridge about the condition of the engine room, mainly main engine and auxiliary machineries. And then master will assess the danger of sinking, capsizing or flooding, and the designated person or superintendent of the ship and port authorities should be informed. So we will be discussing similar what are the events that may happen during our watch in the next slide 2. Thank you.